Good day, folks. Let's see if this works. Yes, it looks like it's working. I hope everyone is having a good night or good day, depending where you are. I understand that sometimes I just do my random live, so here I am. It is 9:26 p.m. here, so I'm just gonna say hello to everyone and wait a little while for a few people to come in and then proceed. I basically just want to talk a little bit today about the displacement current generator that I posted in a diagram of how this works. For now, if you look on the, by the way, over here, the lab, it's just for looks. See, it's not doing anything. It just looks neat. So a little bit of a side distraction, but the LED over here is still running off the peg cell over here. So that flash you see is the actual LED here running off the peg cell. So with that said, I hope everyone is having a good day. And of course, there's no set rules on what we need to talk about. I can go with the flow if anyone has any generic questions, but not too tough on the spot, please, because some of it I have to go back into all the documentation to make sure that I'm right. I don't like saying something if I don't remember correctly, but generically speaking, I'm pretty well good to go with whatever you may have in mind. With that said, it says excellent connection, so we seem to be doing good. So anyways, if my audio is not good or anything, just let me know and I can correct that. It seems like it's good on my end, maybe a little low, so I'm going to try and bring that up a bit. Check 1 2, check 1 2. There we go. So I brought the audio up a little bit. I hope that's okay. So still waiting on someone to tell me if the audio is good. So yeah, I want to get into the switching, but not quite now. I'm gonna wait a few more minutes. I should really start announcing when I'm gonna do this, but I tend to get randoms, so that's giving me a warning. The stream's bitrate is lower than recommended. Seems okay on my end though. Audio is great, thank you. How about the quality of the image? I'm getting a warning on my end that it's saying that the bitrate is lower than recommended, but I'm just using defaults here, so should be okay. Hopefully it's okay. I never had any complaints that the image is actually bad. So just gonna answer on the chat here to show that I'm there. So yeah, it started off with this switching circuit, which I basically want to build still. This is something that I'd like to get out there just for experimentation, very efficient for self-recovering Bedini circuit, but not exactly what I want to talk about tonight. Hello everyone, hello Fractal Woman, hello Cal Quine, and hello everyone, and hope everyone is doing well. Fall is on the way here, well it already is. It's getting pretty cold. Hello everyone. Glad to see there's some people that are starting to join in here. So as I said, this is pretty well an open discussion and always is. So it's whatever's on your mind and whatever it takes us. So yeah, so anyways, gonna wait a few more minutes and get into it. And what was I saying here? I was talking about the temperature. I know I'm just trying to kill some time here. But as people know, I'm in the far north, just a little bit south of the James Bay here in Cochrane, Ontario. So when fall sets, it sets pretty quickly, and then basically 8 months of winter. So, I mean, I get used to it, but the thing is, it gets boring because if you're like messing around with these kind of experiments that need like earth grounds and rods and that sort of thing, I tend to be stuck in the house for all this time because it's 6 feet of snow and ice and the earth freezing so deep. It pretty well kills the any kind of experimentation with earth batteries, good grounds, potential differences, and that sort of thing. So For me, it makes a bit of a long winter, but I guess more time to mess around with jewel thieves, right? That's something you can do indoors. You're from London, Ontario. Oh, okay. So, I mean, believe it or not, there's a big difference because I've been to Niagara Falls, Toronto, that area in the winter time, and there's a big difference because I got back from New York. I used to do a lot of trips. I actually lived in New York for a while, New York City, on 29th Street between 1st and 2nd Avenue, right next to Bellevue. So I did a lot of experiments there. Um, Even got near Long Island and visited. T- well, we couldn't do anything because it was closed, but I was just interested in that area for a while. And yeah, being in Toronto Airport in the middle of January, coming back after being there for a while, I was just not used to it. And it was like 32 degrees Fahrenheit or 0 degrees Celsius. And then I took a first breath because it was like the layover, so you can go outside. And I had my little dog. So it was a bit of a break for that, let her run and go poop and do all that. And I couldn't breathe. I was like choking on the air. That was like 0 degrees Celsius. And I'm thinking to myself, I still gotta go like 600 miles north, and it's gonna be like minus 20 in 1 hour when I get back to Timmins. And believe it or not, since that moment, I never got used to it again. I mean, born and raised in the cold, but haven't experienced, especially a couple years of basically New York winters. You don't want to have anything to do with Canadian winter no more. So. Yeah, ground rods, that's a big problem for the winter around here. I always thought about experimenting with earth batteries because my parents have a field out in the back in the country, a lot of room for ground rods, but what the heck would happen during winter when all of that freezes over? The plans of earth batteries, they don't account for next to permafrost, essentially, right? So I always thought of that being a problem, a quite moderate investment. Sure, it's free energy in that sense, but between corrosion and the ice and everything, what's going to happen by the spring, right? That could be thousands of dollars down the drain, literally. So A for effort, but I don't think Canada's the best climate for any kind of serious earth battery setup, unless you want to put, you know, 100-foot ground rods in the ground and whatnot. Maybe that would work. Sault Ste. Marie, oh my goodness, yeah, that's like 4 hours from here. Getting closer, getting closer. So Sault Ste. Marie, Sudbury, North Bay, that's pretty well. Even though it's still a few hours south, it's very close climate-wise. So if you've ever had Sault Ste. Marie winters, it's pretty well. Um, Maybe you guys get a week more of summer kind of deal, but at the end of the day, it's the same winter. So yeah, so we seem to have a few people. So I'm going to proceed here talking about my efficient displacement current generator. Made a demo yesterday about basically a quarter to half the concept without the advanced switching, just to show you that once those capacitors get loaded, if we put a very high impedance load, and that happens to be calculated, and we put something else there in line with it, which has its nominal working parameters dropped with that impedance load, it will run very long. So the whole idea is to drop, so you don't, there's displacement current, but if you just let it, it's going to be a one-shot event and neutralize right away. You don't want that to happen. So what we want to do is we add a super high resistance load in the path to slow it right down, so it does send it back, but very slowly. And it's the slowdown, it's the accumulation of time that gives us more work through displacement current. The trick is to find something that's compatible with that high impedance. So that's why I was saying you need at least 10 to 20 kilovolts so that once you calculate something like a light bulb that's designed to be, let's say, 60 watts at 100 volts, well, you're going to consider to drop even the impedance of the light itself and the peg cell, and altogether at 20 kilovolts you might end up with about 160 with a drop of 200 milliamps. But the point is, because you're slowing it down so much, it's going to take a while if you wouldn't retrigger it for the balancing effect to happen. So it gives us plenty of time to recharge at every cycle, but the recharge is very minimal because we're resisting very, very high resistance. It's hardly draining because there's still a transfer going from the higher potential to the lower potential, but we're being smart about it and we're recycling most of that minus the losses in the wire, but we're also using the displacement to do additional work, and it's that additional work that could run big loads if we calculate their nominal working parameters and it happens to be in that range. So it's not everything will run off of this. You have to calculate the loads. So basically inductive loads that could work with high impedance, but you can still pulse those in coils and then rectify that and get real DC essentially. So here is the chart. I recommend you go see it. It's in my last video and in the PDF file as well. So here it is right now, the concept I'm talking about here. So the idea here where I'm a little bit in the stall is it requires advanced switching. And when I'm saying switching, it's not the regular switching where you're essentially splitting the transformer in half, and one side you're switching and the other side you're switching. As you see, we need a two-channel square wave switch, but it's two channels and the two channels need to be isolated. So essentially the ground and the plus of each channel need to be fully isolated. So essentially speaking, technically you end up with four channels where two of them are switching at the same time for half and the other two. So complicated way you could maybe build some H-bridge MOSFETs, but that could get anywhere from 8 to plus MOSFETs. So right now I'm thinking maybe using an Arduino with some pulse width modulators, because all the components are already built, right? It's just plugging them in, doing a program. So essentially the idea here is we charge a capacitor on the primary side, but the switch will first charge the capacitor, and then during the second half of the cycle we'll discharge the capacitor on the primary side. But because of the peg cell and the neon load, we're just using pure potential essentially to saturate and trigger the secondary, which by the way works fine because that's what I demonstrated. I had to do it manually with the inverter on and off because I didn't have the advanced switching mechanisms. But the whole idea is, yes, we can use pure potential and step that up on the other side of the transformer. That charged the capacitors there that I had with the help of a rectifier to near 1,000 volts, and then the two capacitors shared the same ground, and then you had the two pluses if you were to short that out, which creates a new potential difference. But I didn't let it short out because we used another peg cell and the neon there, which would limit it very drastically. So at those ranges, as I said, I was getting a few milliamps and I had to reset it every few seconds. But the switch could do that, and because we're hardly using any real power to do it, it would only need maybe a volt or two, even less, every cycle to recharge that primary capacitor and pulse it and keep the secondary side very high voltage. And remember, because we're limiting it with extremely high resistance, we're giving ourselves time, and that time, that lag we're creating, allows us to do real work at high impedance. So a 100-watt light bulb will light up at full range with very little. So essentially we're using voltage to do the work of current through displacement. And we're still going to end up recycling a good part of that energy through displacement and allow us to do additional work. So that's what's very important. The switching mechanism here is very important, and they all have to be isolated naturally and it has to be a square wave. And one could probably make that even more efficient. Also have a second switch that pulses the one that loops the two potentials together through the neon and the peg cell. So if you're look because this is a DC like system because you're even with the high resistance. So if you need AC, you could pulse it with a switch is what I'm getting at. Or as I said in the early in another video, spark gap in instead. But I don't like that idea because that introduces all kinds of noise and whatnot. But you definitely have the potential to initiate a spark gap and then feed that into whatever else you want to feed. But the way to really maximize this is take advantage of the dual switching, but all essentially the channels, meaning the conductors of left and we're not dealing with stereo here. Um, Plus and minus, they all have to be isolated. So four channels, but two of them are synchronized at the same time between each cycle. So I'm just going to read the comments here. Yeah, so what the peg cell is doing and what I'm trying to get across here is to do this, you see, if we were to say, let's put in a 90K or even 900K resistor across, what the resistor would do is, yes, it would allow to drop the current, but if you follow the Ohm's law, it's also going to drop the voltage potential drastically as well. So what happens is your loop no longer has that high potential difference to take advantage of the displacement current. So you've done half of the requirement through the high impedance, but the resistor needs to be special. It needs to contribute as well. So the resistor needs to essentially act as a negative resistor where it also contributes to giving you more potential instead of taking it away. So what the peg cell does is it simulates essentially a very high resistance load across the loop. So it slows down the flow the displacement current, so it doesn't allow it to come in one shot. That gives us our drag, but it doesn't to drop the potential down because the peg cell has its own even if it's just 1 volt, it'll be whatever plus 1 volt. It acts like a series DC cell in the loop. So instead of dropping your voltage, the only thing that's going to drop the voltage is your 100-watt light bulb, which is a regular resistor in a sense. So once you calculate that, like I had done, this is where you get that 160-volt drop that I was talking about. It's not the peg cell that drops the voltage, it's the traditional load that's in series with it that will do traditional things. So if you can calculate that drop, which what I said, when you've got 20,000 volts and what all you have left is 160, that's a drastic drop. But that happens to be nominal range of that device. It will run as far as it's concerned like it's being fed off regular energy is what I'm getting at. Because 200 milliamps or so at 160 volts is very close to, if not a little more than 60 watt. So your 60 watt light bulb would actually shine brighter than if it was plugged into the socket. So that's what I'm getting at is the peg cell has a very unique feature. It gives us that lag, but it also allows the potential and not only allows it, but it tops it off a little bit. So if your peg cell puts out 12 volt, it's going to contribute an additional 12 volt to that loop. The triode is supposed to tap multiple AV plugs on one wire. Yeah, so what I've done for that one is every capacitive plate has its own isolated AV plug with cathode and anode on a cap dump. So when it reaches the trigger, it goes back into a common battery. So I don't remember how many, but if I had 16 of them, that's 16 different one-wire systems feeding off that capacitive plate. I layered them all, you know. So one capacitive plate, and then it was a layer, of, I believe, of electrical tape, and then a coil layer, and then another layer of electrical tape, and then another layer of foil around, and then on and on like that. And they all had AV plugs. So like one oscillated into the other kind of deal. So it was like its own reactive kind of thing built in. Yeah, yeah, exactly. But here the peg cell does it for us a lot less complicated. It's an inherent feature of the electrostatic potential that it also has. So it acts as a series DC cell. So it contributes potential, but it acts as a normal DC based on whatever electrostatic current that is able to provide, which is very minute amount based on a DC cell series. That's the maximum that it's going to allow the whole series to provide. So it's using a natural system of the electrostatic to give you that high resistance without dropping the voltage along with it like it normally would if you were to put like a 900K resistor across that. So it gives you the potential to run something else in series with it. So yeah, very, very important points that even Don Smith had these resistors, but he didn't get into the details of because they had to be special and whichever way you want to do doping and whatnot, there's but you have to come up with this novel semiconductor-like device that's going to give you an effect of resistance to the current but allow the potential to cross it with little, if not a gain. The peg cell actually gives you a gain of potential while dropping the current. So it doesn't have to be a peg cell, but as long as it has that characteristics. So for example, like I said, it gets really funky past 20,000 volts. You need to incorporate other systems to manage the interference and the skin effect, but obviously more voltage means more displacement. So Don Smith playing at the 100 kV and more, what he did is instead of using a peg cell, for example, he replaced the peg cell with the ion valve, which essentially took care of limiting the current but giving you a pure potential, and it was also giving you its own because it took advantage of ionizing the air and giving itself it but the difference is it needs a trigger, but with the help of the trigger it gives you an electrostatic potential due to its mechanism. So at the end of the day, the ion valve at very high voltages driven does the same work as the peg cell does. The peg cell allows us to do what Don Smith was doing, but at much safer voltage levels, essentially. Yeah, the mag is great, but Tom Bearden puts a few things out with the mag. First of all, he doesn't mention, well, he hints about it throughout all of his work, but then in his patent doesn't say a word about it. For this to work, you have to use barium ferrite or something like it core. And he hints about it all the time, but doesn't go there. And everyone who's tried it, that's what's missing. And you have to make sure also that it wouldn't hurt to even custom make your core with a material that requires the most minimum voltage for saturation purposes. So there's a few components to the recipe there that Tom Bearden fails to mention in his patent, but if you know from stitching the pieces together, the mag should work fantastically. So yeah, I think I pretty well covered what I wanted to really well talk about here. And I hope people are watching these lives. Like, I understand not right away, but once I'm done, they can go back to it and get the information. You know, sometimes they hit me with this in the comments and then I actually address, but they don't see the follow-up. So it's very difficult sometimes, right? So, yeah. So I'm going to stick around for a little while more here. I'm pretty well done here of what I had to say. If anyone wants to talk about anything here, I'll gladly try and answer some questions. And after that, I will probably wrap it up. And this seems to be working pretty good still. Um, yeah, I just need to figure out the advanced switching, and we're good to go pretty well with that. Your interactions help me. I'm a biochemist. Physics is a second language for me. Awesome. Whatever works, right? I mean, if I can inspire, help, that's um, that's all really I could ask for. Um, maybe a little more YouTube interaction would be nice if you folks. I know you already do, so I guess I'm preaching to the choir, but it's for the new ones that come along to share, subscribe, and interact because it's not for my own personal ego. What happens is the YouTube algorithms. The more interactions, the more YouTube pushes, right? So instead of having people, I hate to say it, like Electro Boom going on your feed recommendations once in a while to find my stuff, right? So that's all thanks to your help. But for that, you need to interact. And it's something that you have to do on your part. It's not something that I can do on my end. I could just encourage you folks to do that. And it seems to be working. I mean, I started off, I guess, with one, and we're at 3,000 now, so 3,000 followers. I mean, yeah, I guess it's an echo chamber in a way, but a pretty strong one at 3,000. I mean, it'll resonate a few times at least. Won't hurt, right? So they'll hear us at 3,000, plus everyone else who's in my circle doing the same thing, and they have their own channels, and they're doing pretty good as well. So as a collective, I'd say, if we've got 25 to 50,000, we're doing pretty good, folks. No, the plasma globe is not charging the system, it's just there for looks. I said that earlier today because it looks neat. See, I can turn it off here. It's off, very far away. This has been running, since March. March, I would say. Well, maybe not. I'm not sure. You don't hold your breath to it. If you really want to find out, go back into my playlist, Power Cells, and the first time when I'm holding it and showing it, it was sometime in the spring, early spring. So that's how long it's been working. No corrosion. I still have the original foil plates on that thing. But I just put the LED for looks and conversations. But I've said a lot. This is hardly the main application for the PEG cell. It's not known for providing current and running traditional loads. It's better to use it for, as I'm doing right now with what I want to do, for a circuit as a novel semiconductor, one that could gate current and allow potential to pass. You'll do a lot better using the PEG cell for something like that because you need like 1,000 of these to charge your 12-volt battery over here. So, I mean, will work, but not practical as is, right? So instead, use it as a part of something else that would get the job done a lot better if it's working with something else. Yeah, he used the plasma globe to charge caps, and I have a video from about a year and a half ago where I do that. I've got the plasma, but I made my own twist. I use magnets to amplify the effect, which work very well, actually. So I still have that video on my YouTube. Yeah, since March, I guess. Maybe April, I don't know. I'd have to go back on my YouTube. It was in the spring. It was one of the first cells I built. And it's the same one. No corrosion. But it doesn't run anything more than an LED, really. They'll charge capacitors. But like I said, I had better luck using them for other devices in complement of. Using them as negative resistors and things like that does a lot better than trying to use it on its own just to run something. Even though technically it can, you know. And yeah, it still lights up. Hold on if I can. I'm gonna try and show you that. Maybe if you see that. I gotta get the angle right. Light's enough to leave a glare around the desk anyways when I put it down. It's about a milliamp. You know, do whatever you want with it, charge a capacitor. And the potential on this one, because it's a multiple cell, I'll tell you right now, it varies literally from day to day. If I put the meter on there, disconnect the LED real quick and put the meter on. See, today we're getting 10.8 volts. See? I don't know if you can see that on the camera. That's pretty good, almost 11 volts. But the LED doesn't fry because it's got so little current. Trying to get it to aim at the camera because it looks off if it doesn't smile at the camera. There we go. So that's what that does. About 10 point some volts today. But like I said, that varies all the time and it flickers around. It's very flickery, which is an inherent feature of solid state power cells. Just reading here what people are saying. Nice to see there's interaction. That's good. So yeah, so I got all these different peg cells here. This is one of them that I built also in the spring. Still works fine. This is the one that I used a bit of copper oxide in there. It's like a brick, real brick. It's solidified real nice. Because with just the peg stuff, it tends to get brittle when it gets real hard. You know, easy. I've broken about, you know, 4 of them, dropping them on the ground. And when you drop them on the ground, they just shatter like it's like sugar. You know, when it crystallizes strength wise. So I found the copper oxide really helped to solidify the peg once it dried out. It's almost like a cement. So yeah, I hope that's about it, I guess. I'm gonna wrap it up there again. So there doesn't seem to be any questions directed to me. I will be talking about what am I saying? New power cell electrolyte that I want to cover. I have all the research done, but I just got to make an actual video presentation of it. That's going to be very interesting because it may offer the same thing the peg cell does, but a little bit more potential and a little bit more current and a little bit more stability. So, yeah, anything is always good to explore, right? So, I'm going to be talking about that very shortly. And with that said, again, thank you everyone for spending some time with me. And let's all work together and spread this information, the general stuff, anyways. If it's just as simple as a jewel thief that could be efficient to help for lighting, that's a start, right? So share that to someone who might be into it. And with that said, folks, have yourselves all a great day and thank you once again.